Hey guys, welcome to our channel. So I've been thinking about this one for a while. I wasn't going to do it, and I'm going to because I've been thinking about it, and I had said that I would never discuss my position about the Earth models unless I thought that it dealt with the Mandela Effect. And I've been thinking about it, and now I think it does. Okay, I think it does, and I'm going to explain why. All right, I'm going to be throwing some numbers at you. Okay. Let me just start by saying I'm just not just picking on one thing here. Right? I think there's problems with both models, and that is the problem. That's why I think it has to do with the Mandela effect. Because I believe there's a problem with both models. For one thing, for the flat earth model, dust, if you watch it in a camera, on a night camera and lights, it's not flat, guys. These dust particles aren't flat. They don't gather together flat. They gather together. It looks like a round sphere in a camera at night. All right? It naturally forms spheres. And our planet's made of dust. Dirt, which is dust and clumps together, but this stuff doesn't clump together flat. So that's a problem. Okay? Now, that's one problem with it. Okay? There's the other problem of an artificial dome with nobody to build it. You'd have to have a functioning model of how people survived somewhere in order to build an artificial place to begin with. All right? So there's problems all around. I mean, in an infinite flat plane, there's problems with that because you'd need multiple suns and moons and all sorts of things going on there that you, as far as I know, you don't have. So, but everybody pretty much thinks or conforms to this globe Earth theory, and I want to throw some numbers at you, and then we're going to talk some quantum physics. So if you just stick with me for a minute. So they say the Earth spins at 1,040 miles an hour. I'll post these links, so I'm not just making these numbers up. 1,040 miles an hour in a spot, so figure around 1,000 miles an hour. So that's the Earth just spinning like a merry-go-round, right? So then you've got the Earth revolving around the sun. And it's still doing this, but now we're revolving around the sun. And it does that, excuse me for a moment, at, yes, 67,000 miles an hour. All right. So now you've got 1,000 mile an hour spin, and you've got a 67,000 mile an hour revolution around the sun. And the sun is, and now you're like on a spinning apple ride, like where the apple spins and then the whole thing spins. So it'd be like the worst spinning apple ride you've ever been on, but we're not done. Okay, the the sun spins around the center of the galaxy at, excuse me for a moment, I don't have these memorized, I should, 486,000 miles per hour. All right. And so we're doing that too. So and then we're and then the galaxy, so that, excuse me. So now you'd have to have if you're comparing this to a ride, you'd have to have a spinning apple somehow at the end of a scrambler. And then you'd be somewhere close, I guess. All right. And then you can add to that that the galaxy is hurtling through the universe, through space, at 2.1 kilometers or 2.1 million kilometers an hour, which I did. I went to a calculator and figured that to be 1,304,879 miles per hour, well, point 0.5 something or other, but that that the galaxy is hurtling through space. So you could hook that spinning apple scrambler ride, probably throw the gravitron in there somehow, and you'd have to hook that up to a vehicle and drive it down the road at a really fast speed on top of the ride itself. So you can imagine we're cooking according to the model. All right. And so those are our speeds now, and we're doing all that at once, by the way. So you can imagine that according to that model, the Earth, the sun, or nothing else is in any place for any very long length of time. I couldn't even calculate that. I didn't calculate that. So you just imagine that with all this movement, things aren't where they are very long. Now, let's talk about quantum particles shifting in and out of phase. Past, present, future, whatever's going on. The Earth is in different parts of space at different points in time. So if a particle even shifted 5 minutes in the past, the Earth wouldn't be there anymore. 5 minutes into the future, the Earth wouldn't be there yet. It's only where you are when you are. So if you had particles shifting in and out of phase, when are they going to shift into empty space? You would think that there would be more of a chance that they shifted into empty space with all that movement. So that's a kind of a problem with this Mandela effect, assuming it's happening on a quantum level and these things are shifting in and out of phase. Can you really have all that movement going on? Also, can you? I I'm not a quantum physicist, and my cousin is, but I haven't seen him to speak to him, and he doesn't have internet at the moment, so I can't really look him up on the internet either. But next time I do, I'm going to talk to him about this because, and I'm asking any of you to. I mean, this is the point of this video. I mean, what do you guys think? I think in order to really figure this thing out, we'd have to get a functioning model of how things actually work. And I don't think we have that. I think we have flat earth people on one side, and they know that they're right. And I think we have globe earth people on the other side, and they know that they're right. And there's nobody working on, hey, what if they're both wrong? I even dabbled with the theory of maybe we were on Atlantis and they put a dome over it and sunk it to the ocean and that was just a region of the planet. But then you've still got the whole hurtling through space and you'd still have particles shifting in and out of phase and you'd have a problem there, right? I think you would. And then don't even get me started on the space vacuum because I work with a vacuum because we have to prep for paint, prep for floors, prep for all sorts of things in the construction business. And I can tell you that gravity and nothing, no centrifugal force or nothing else holds even a rock when I'm sucking it up with my little shop vac. Now let's add infinite space vacuum. It's going to suck everything off the planet. I don't know how you get around that. I work with a little vacuum. It's not an infinite space vacuum. It's a super vacuum. Space is a super vacuum. I'm sorry. So it's not an infinite super vacuum, which I think you'd have a real super problem with a super vacuum. So, yeah, and that's just from working with a littler version of one. So I think you got all sorts of problems, and I don't know that it's not important to figure out a functioning model so that we can figure this out. The particles are shifting, but is there all that movement going on? Because if there is, that means something, doesn't it? I think it does, but I don't think there could be all that movement going on, or else particles would be in space. Just shift into space, and you'd just be floating in space, and that's the way it always was at some point. And that hasn't happened, at least not yet to me. But let me know what you think, guys. I don't want to run this video any longer, but if anybody has any ideas about a functioning model that doesn't have all the flaws, I, I don't want to debate, but I think I think it should be brought up that if you've got all this quantum shifting and you have all this movement, you have a problem. And I don't know. I don't know, guys. You can thumb me up if you think I'm on course, and you can thumb me right down if you think I'm off course with this. And I'll get right back into music this weekend. I kind of had a rib injury over the last few days, and I went to work, and I haven't felt much like doing stuff. So I feel a little bit better over the weekend. So hopefully over this weekend I'll get into looking for some more music and stuff. So beyond that, sorry it ran a little long, but thanks everybody for your subscriptions, your likes, your dislikes, thumbs up, thumbs down, and all that good stuff. And I hope you have a great rest of your evening. And we welcome your comments and feedback as always and appreciate it. And have a great rest of your night, guys.